All right, let's take a look at today's lesson. Today's lesson is a combination of some inequalities, some nonlinear inequalities, and absolute value written as a piecewise. So for us, many of us have, the inequality lesson or portion of this lesson would be a review, mostly a review. The absolute value of a piecewise, that's going to be pretty new. So let's kind of work through our inequalities first. This first box is just a standard. What happens when you have a less than, an absolute value less than, or absolute value greater than inequality to work? So if it's less than, if you recall when learning that was like an and, if we remember those words. And if it's a greater, it was an or. And to translate the absolute value inequality into non-absolute value, these are the patterns that you would use to do so. The patterns are right over here. But it means more than just this. I need to make sure we really understand what's going on, because these are the normal things that go on. These are the normal patterns. What happens when we have something not normal, which you probably will have? So let's look at the options. So let's look at a couple of different graphs. I just want to explain these graphs. So let's say we have a graph where we're doing two different pieces. We're solving two different inequalities. Let's say one inequality has us with less than 5, and one inequality has us greater than 5. Let's say our graph looks something like that. So if this were a less than or an and, then our answer would be where those two graphs are in common. What do they share? So if it was a less than, which is an and, they share from -3 to 5. That's what they share. Our answer would be what they share in common. If this were a greater than or an or, if this graph described a greater than an or, so greater than is everything that is affected. If this were the graph of an or, our answer would be -infinity to infinity. That's what our answer would be. So depending on which kind of inequality you have would depend on how you interpret the graph. Very important. Another option, what if we had something that looks like this? Let's say we're going, we have the same, let's say we look like this. It's going that way. That is a traditional or normal OR graph. Regular or normal OR graph. So if this were a greater than, which is an OR, our answer would be really everything that's touched. So what is so we know that x would be less than or equal to -3, and x would be greater than or equal to 5. That's what our answer would be if this were an OR. But what if it were an and? What if it were the result of an less than equation? Do these two graphs intersect? No. So it would be no solution. The empty set, it wouldn't be an answer. So it's really important for us to recognize what kind of an inequality we're dealing with when we have an absolute value inequality equation. So it'll just, that's the difference. So if it's an or, it's basically everything. If it's an and, it's only the parts that are in common to both of the graphs. Does that make sense? Do we kind of remember that maybe? Okay. So that's our portion on inequalities for the absolute value inequalities. We'll deal with some other inequalities in the lesson, in the examples. We'll get to those in just a moment. The second part of the lesson has to do with absolute value. This is the definition of the absolute value of x. This is very important to us. We use this in calculus. So we need to know that is the definition. There's no, the equal sign goes with the top branch. That's how it's defined. So let's look at the graph of absolute value of x and try to determine what this is talking about. So when we have an absolute value, we can't do calculations with that. Like I can't take the derivative of absolute value of x, which is why in calculus we have to translate it to a piecewise function. We have to take the absolute value bars off. And that's what this process does, is taking the absolute value bars off, it turns into a piecewise function. So what this piecewise is telling us is that when x is bigger than 0, my equation is y equals x, right? That's the line, y equals x, is it not? So when x is bigger than 0, I use the equation y equals x. When x is smaller than 0, it's this branch, and I use the equation of negative x. This is y equals negative x. So are we clear what the absolute value, the piecewise, does for us? It takes basically the guesswork out, and it really tells us which branch belongs to which equation. Does that make sense? So that's what we're doing. If I didn't know what was going on, we're going to be doing sign analysis today. Hopefully you recall that. If I was going to be doing sign analysis on this, I would put where would this be 0? X, well, at x equals 0. On the left side, if I put a -1 in, it would give me a negative, and I'm not talking about with the absolute value, I'm just talking about x. Okay, that's without the absolute value. We're testing. We would do a test in the equation x. This is before I wrote it into a piecewise function. I'm showing the two different ways to write piecewise functions. One is to think of it graphically. What would I look like if it was graphically? One is to do it with sign analysis. And so if I were to put a positive number here, I get a positive. So this also tells me that my piecewise, when I'm negative, I need to do the opposite of my original equation. When I'm positive, I do my original equation. Okay, and that I'm getting some confused looks. Hopefully that'll make more sense when we get to the examples. Okay, so there's a couple different ways I want you to think about what it is that we're doing so that you understand what we're doing instead of just merely copying down a formula. Because we're going to encounter some that may be not just, as easy or regular as that. Okay? So here's some properties of absolute value. I think we're all familiar with property A. If I have like -1, the absolute value of -1 is 1, so that kind of thing makes sense. You may or may not have already known, if I have the product of two entities that are absolute valued, I am allowed to break them into pieces and do the first entity absolute value of it times the second one. Same with the quotient. I am allowed to separate those into absolute value of the numerator over absolute value of the denominator. D is something that we really don't use that much. It has to do with an inequality, not an equation. It just tells us that if I were to do this operation, A plus B, and then absolute value it, that quantity is always going to be less than the quantity of, if I separated them out, absolute value of A plus absolute value of B. So we just don't use that very often, but it was something that would be fun to talk about. Right? We're not going to use it, but it's fun to talk about. Alright, so here's our general guidelines to writing absolute value as a piecewise function. The first thing that we would do is set the expression inside the absolute value equal to 0 and solve. That expression in here is x set to equal 0, and there's nothing to solve, right? X is 0. That's where our piecewise function will split. Notice, see, there's where the splits are, at 0. Place the value or values that are obtained from step 1 on a number line and do sign analysis. That's what we did here. So 0 is what we got when we did that. I plug a -1 in here. I get a negative number, a positive one, a positive number. There's my sign chart. The intervals where the expression is negative are written in the piecewise function the opposite of the original. So this is a general guideline. This is not always true. I'm going to show you where this doesn't, that's the general guideline, just general. This is not always true. Like I think exam number 3 on your daily work is against this, and we'll do that problem together in class. So this is a general guideline. All right, so let's jump into on the next page, go to our examples. All right, so we're going to start with what we are familiar with, the inequalities, solving the nonlinear inequality. The first one is a polynomial. What we would do is we would factor it. Then we would put those, each of these factors, we would set equal to 0 and get that number. And so the numbers are 2 and 3. Okay. Then we're going to do our sign analysis. Now this should be a review, but I'm going to actually kind of write it all out for us to make sure we're okay. So I would encourage you not to write down your test numbers. I think that can be confusing. So if I just look to the left of 2, I would use a 0 because I like 0. If I put 0 in here and here, I would get a negative times a negative, which would give me a positive. So that section would be positive. Number between 2 and 3, let's say 2.5. If I use 2.5, that would give me a negative number, and 2.5 here would give me a positive number, which means that section is negative because a negative times a positive is negative. In the far right section, I'd pick like 4. If I put a 4 in the first factor, it gives me a positive, a 4 in the second factor, a positive, and that section is positive. Is everybody okay with the sign analysis? All right, so our answer needs to be numbers that are smaller than 0. Numbers that are smaller than 0. So negative numbers are smaller than 0, right? So our answer is going to be this middle section. Those numbers are smaller than 0, between the negative numbers. Now, we have to be cautious about whether to use a parenthesis or a bracket. Since our inequality is just less than, there's no equal sign, we don't even have the opportunity to use a bracket. It would have to be equal to use a bracket. We don't have that, so it's going to be parentheses on this one. Okay? We okay with that? All right, the next one is a rational inequality. So we're going to solve this like we did the equations. We're going to get a common denominator, move everything to one side, add it together, just like we did in the last lesson. So I have 1 plus x over 1 minus x, and I'm going to subtract the 1 over. To get a common denominator for 1, I would have 1 minus x over 1 minus x, and that leaves me a 0 over there. Okay, so I got a common denominator. Let's combine them together. So I have 1 plus x minus 1 minus x. We need to be real cautious and be sure that we distribute the negative, the subtraction sign. So 1 minus 1 is 0. X minus a minus x gives me 2x over 1 minus x greater than or equal to 0. So that is my simplified inequality. So what I'm going to do now is sign analysis. The things that I put on my number line are the zeros of that equation, which we know is when we set the numerator equal to 0, which would be 0. And the undefined. Where is this undefined? It's undefined when I set the denominator equal to 0, and it's undefined at 1. So 0 and 1 are going to be the numbers that belong on my number line. Now some students like to so this 1 can never be equaled, right? It's where we are undefined. Some students, what they like to do on their number line is put a hollow circle here to indicate that it can't equal 1. And that's a great idea. You don't have to do that if you don't want to, but it you know, at least will remind you you can't use a bracket on that. Okay, so now let's work on our signs. So I pick a negative 1, so I would have put a negative 1 in the numerator, it'd be negative. In the denominator, a negative 1, what would that do? 1 minus a minus would be a positive, wouldn't it? So that section is going to be negative. Okay, on the next one, like 0.5, we'll put a 0.5 in. If I put a 0.5 in the numerator, it's positive. 0.5 in the denominator, it's positive, so this section is positive. The last one, say a 2. If I put a 2 in the numerator, it's positive. A 2 in the denominator would be negative, and so that section would be negative. So those are my signs. My answer is going to be where we're greater than or equal to 0. Greater than or equal to 0. So it's going to be the positive sections. And we are allowed to equal 0. So this positive section, we would say, goes from 0 to 1. Now, why did I use a bracket on the 0 and not on the 1? Well, because 0 is where it's equal to 0, right? But 1 is where it's undefined, so I can't ever bracket in an undefined. Okay, how are we with that? All right, last one, the absolute value inequality. That's a less than or an and. I like to translate it like those formulas, I guess, on the other page. So I would do -7 less than equal to -2x plus 5 less than equal to 7. Do I have to translate it like that? No. An alternate way that I could translate it, I'll just kind of go over here to the side, is basically drop the inequality. So -2x plus 5 is less than equal to 7. That's one equation that or inequality that I would solve. Then what I would do is I would copy that down again, -2x plus 5, reverse that, and alter, do the opposite of that right side. Notice how these are the exact same thing as this. They're just written in 2 pieces instead of 1. It does not matter to me which way you do it. Are we clear on that? So some students like to solve these separately, and they get really confused when they are compounded together. Some students don't have a problem with them being together and are fine solving them that way. I just wanted to show you there is another way. All right, so I'm going to solve them together. That's how I would typically do it. I would subtract 5 from both sides. So when I subtract 5 from both sides, I get a -12 less than equal to -2x less than equal to 2. That's subtracting 5 from both sides. Then I would divide everything by -2. Do you remember what happens to the inequality signs when we divide by negative? It flips them, right? So this is going to flip both signs. So I'm dividing all sides by negative. So that gives me a 6, flips the sign, -1. Now, I really can't leave it like that. That's actually very troubling to me, the way that looks. Our answers are written from least to greatest, not from greatest to least. So I would rewrite that to be -1 less than or equal to x less than equal to 6. Now, we could just be happy with that and go on our little way, but we need to be cautious to make sure that that's the actual answer, right? What if the graph doesn't support that? So let's just make sure that the graph supports what we just did. So we have a -1 and a 6. So it says 6 has to be bigger than or equal to x, or x has to be less than or equal to 6. So goes that way. X needs to be greater than -1, so it goes this way. Are we doing an and or an or? We're doing an and. So which portion of the graph is the answer? The common portion, right? What's the same? These are the same from -1 to 6, so this is the correct answer. What if we were doing a greater than, a greater? What would our answer be? All real numbers, -infinity to infinity, right? All real numbers, because it would be a greater than or an or. So just be cautious, okay? All right, now let's go to our writing the piecewise, or the absolute value as a piecewise. So we're going to follow the steps from the previous page. We're going to take this, what's inside here, set it equal to 0. So 3x squared minus 8x plus 4 equals 0. We've got to discover where this piecewise function splits. What are the splitting points? So I factor that, and I get 3x minus 2 and x minus 2. Alright, so let's do our number line. So that gives me 2/3 and 2. Okay. Are we comfortable enough with, and remember enough with our, checking these intervals, our sign analysis, that you trust me to just put the signs up there? Are we okay with that? Right, I don't need to go through and do that. Okay. So the signs that we have here are plus, minus, plus. So what does this tell us? This tells us that on these two pieces, the plus pieces, we're going to use this regular equation, and on the negative piece, we're going to alter it. Why would we do that? I need you to understand, why are we doing that? Let's consider what's going on with the graph. Just the regular 3x squared minus 8x plus 4. What's going on with that graph? What's going on with it is it looks like this. The left and the right, far left and far right portions are above the x-axis, so they're fine and good to go, right? Absolute value means the y is positive. They're good to go. But what about this middle section? This middle section is below the x-axis, right? The y value is below the x-axis. That can't happen with an absolute value. That's why we negate it. We do the opposite so that it'll flip up. Okay, that's what we're doing. That's what we're physically doing when we write the piecewise function. We're forcing this to be flipped up. Okay? That's what we're doing. So I need you to understand what we're doing, not just formula. So I would typically start with the biggest piece because that's what the definition does. So I'm going to start with this portion over here where we're bigger than 2. So we would have the regular thing, 3x squared minus 8x plus 4, and x is greater than or equal to 2. The middle portion we have to negate. We have to do the opposite of it. So the opposite of 3x squared minus 8x plus 4, that exists between 2/3 and 3. 2/3 less than x less than, 2/3 and 2. Now, let's talk about where we put the equal sign. Notice how I started off with the equal sign. That's just because the definition starts off with the equal sign, so that's what I'm going to do. Hopefully we recognize that I can't put an equal here with this 2 also. That would be, it would not be a function that way, right? We can't have it equal to 2 in 2 places. So the 2/3, where do I put the equal with it now or do I wait? It doesn't matter. You just pick one. It doesn't matter to me. Just for fun, let's wait. Let's wait to the other piece. So the other piece is regular 3x squared minus 8x plus 4 when x is less than or equal to 2/3. And there's my piecewise function. Now on the middle piece, notice how I put negative in the parentheses and I didn't distribute. Okay, you don't have to distribute. If you want to live on the edge, right, live dangerously, you can distribute. Because if you get your signs wrong, of course it's going to be wrong, but you can distribute. You're welcome to. I'm just not going to. I'm going to write it as the opposite of that. Okay, so it's up to you. All right, questions on that first one? Are we okay? All right, let's move to the second one. Looks a little crazier. I have an absolute value combined with non-absolute value stuff. Okay, so that's a little weird. We haven't done that before. So what I'm going to do is I'm going to write this as a piecewise. We have the definition of it. We know how to do that. So it's x when x is greater than or equal to 0, negative x when x is smaller than 0. And I'm going to add to that piecewise 3x plus 1. That's what I'm going to do. Okay? So what I'm going to do is I'm going to take this each branch of my piecewise, and I'm going to add the 3x plus 1 to it. I mean, that's really all I have to do. It's not I mean, it looks weird, I know, but it's not terribly complex, this kind, where it's a mixture of an absolute value and non-absolute value. I'm just going to add the 3x plus 1 to the top branch. And so x plus 3x plus 1 is 4x plus 1. I'm going to keep the same restriction that x is greater than or equal to 0. On the bottom branch, negative x plus 3x gives me 2x plus 1. And that's where x is less than 0. And that's basically what we would do when we have a mixture of a absolute value and a non-absolute value. That's what we would do. Okay? So the last one is probably the most complex one. It's an absolute value plus an absolute value. That one is a little bit complex. Okay, so let's work through it. I'm actually going to move this up a little bit so we have more room. Does everybody have B copied down, what they need? I'm just going to kind of erase this this right side. All right, so let's just get some room in here. Come on. So when we add a piecewise to a piecewise, I mean an absolute value to absolute value, two piecewises together, that's a little bit weird. A little bit troubling, so let's what we're going to do is we're going to write each individually as a piecewise first. Okay, we're going to do that first, and then we're going to worry about the adding part. The adding part is the more complex part. So it's going to write each one by itself. So we know this is x when x is greater than or equal to 0, and negative x when x is less than 0. We know that that's what that one is. All right, that's just the definition. The second one, let's see, if we set x minus 1 equal to 0, we get 1. It splits at 1. Right? It splits at 1. And so it's x minus 1 when x is greater than or equal to 1. And it's the opposite of x minus 1 when x is less than 1. Is everybody okay with those two piecewises by themselves? Okay. So in adding them together, a little bit complex, we have two splits, and actually what I'm going to do is I'm going to demonstrate this on a number line. I think this is the easiest way to see what's going on. I'm going to show you with a number line what's going on. So when x is bigger, let's work on this side first. When x is bigger than 1, I look at this piece. Which of the pieces, the top and the bottom, goes when x is bigger than 1? The top piece, right? So I'm going to write it down. Do you have to show this work for me on your paper? No, I'm showing this to you so that I hope that you completely understand what it is we're doing. All right, now let's look at this other piece. Which of the pieces belongs in the section when x is larger than 1? The top piece or the bottom piece? The top piece. Okay, so those are the two equations I'm going to have to add together in a moment. I just want it all laid out first. Now let's look at the section between 0 and 1. Let's go over here. Which of these pieces belongs in the section between 0 and 1? The top piece or the bottom piece? The bottom one, right? Because that's when x is less than 1. So negative x plus 1. I'm going to go ahead and distribute. All right, so on this other piece, which of these pieces belongs when x is between 0 and 1? The top or the bottom? The top one, right? That's when x is bigger than 0. So, okay. Do we kind of understand what's going on? We see how I'm allocating these. So on this last piece, so we want to be smaller than 0. So we go back over here. Which of the branches belongs when x is smaller than 0? Well, this bottom one, right? So negative x plus 1. And now on this one, the first one, which of the branches belongs in the area where x is less than 0? That would be the second one, negative x. Okay, now I have them all laid out. I'm just going to combine them together and put them where they belong. So let's look at what our answer should look like. So let's start with the biggest piece. So I have x plus 1. So that, excuse me, minus 1. So that's 2x minus 1. And that section is good when x is greater than or equal to 1. Okay. The middle section, when I combine those two equations together, when I add them, because that's what we're doing here is adding, I get 1. And that section is good between 0 and 1. Okay. I already used the equal sign on the 1. I can't again. And this time I'm going to wait. I'm not going to put the equal sign. I'm going to put it on the last piece. Again, doesn't matter. Just pick one or the other. This last section, I add those together, and I get negative 2x plus 1, and that works when x is smaller than or equal to 0. And that's like the most complex one that we're going to be working with absolute value to piecewise. Okay, are we okay with that? Okay.